Hello, this is Mr. Wynn, and today's video will be about graphing reciprocal functions. So a reciprocal function has an equation of the form f of x equals 1 divided by a of x. So that you see there's a constant or a number on top, and the bottom is some polynomial. It could be linear. And the bottom cannot be 0 because you cannot divide by 0. So here's the parent function, 1 over x. That graph is what we call a hyperbola. There's domain and range. There are asymptotes. Notice x equals 0 is an asymptote. We cannot have x of 0 right here. Reason it cannot be 0 is because that would make this denominator 0. That's our restriction. It also has a horizontal asymptote, f of x, or y equals 0. So notice we can't cross this line either. So there's two asymptotes, one vertical, one horizontal. What else? There's a part where it's not defined. Now the domain is limited by the values for which the denominator is non-zero. So this example right here, you can't have the bottom being 0. So that's why x cannot be negative 2. If it's negative 2, then negative 2 plus 2 is 0. Negative 3 by 0 is undefined. Second one, to the bottom equal to 0. Add 5 both sides. X cannot be 5. If x is 5, that bottom will be 0. And here, something's top, x equals 0. You can't have 0 down there. So let's see. Find the values for which this is not defined. Well, again, I cannot have 0 on bottom. I'm going to set the bottom part equal to 0. So this is a regular algebra problem. If I subtract 5 both sides, 2x equals negative 5. Divide by 2. X equals negative 5 over 2. Now, we're going back to using fractions, no decimals. You could say negative 2.5 since it's exact, but no rounding. Alright, so that's where it's undefined. Now we're graphing. Well, let's see, here's the general form. Where each letter does the same thing as it always has. So A is still vertically taller or wider, flipped upside down or not. There is a start point. It's going to be 1 comma A. B is horizontally taller or wider, like stretch, and it's flipped sideways or not. But for regular algebra 2, do not worry about B. H shifts left and right. And it's the vertical asymptote because that comes from the denominator equal to 0. And then K shifts up and down, and it's still our horizontal asymptote just like before. And I have a note down here. Always draw in the top right section unless A is negative. If A is negative, it means flip upside down, meaning draw in the bottom right section. And you'll see when I split up a graph, there'll be 4 sections. So we're going to sketch this. I put the steps up there. Find the restrictions, find the vertical asymptote, then the horizontal asymptote, draw those two, then sketch the curves. So let's do the vertical asymptote first. Vertical asymptote comes from the denominator equal to 0. So if I solve this, I subtract 2 both sides, x equals negative 2. So that's my vertical asymptote. X cannot be negative 2. The moment it's negative 2, the denominator is divided by 0. You can't do that. So that's the vertical. Alright, horizontal comes from k. Well, k is just negative 1. So that's my horizontal asymptote. Alright, so right here, alright, vertical asymptote. Alright, now I just draw my graph. I'm going to draw my vertical asymptote. X is negative 2, so do not cross this. That's x of negative 2. Put negative 2 there. And horizontal is y at negative 1. So let me draw this one right here. I'll use red as well. Let's call this negative 1. So notice there's 4 parts of this. There's the top right of that red area, top left, and bottom right. Since A is positive, A is 1, I'm going to draw my curve on the top right. So it's going to look like this. It approaches this up here. It hugs that line. And then I'm going to just flip around to the other side. Just alternate. And that's the picture. That's the domain and range. Domain. Notice it goes left forever, right forever, but there's one x value we do not use, and that was negative 2. So x cannot be negative 2. Everything else but that. Our range, it goes down forever, negative infinity, up forever, positive infinity, but we never cross y equals negative 1. So everything but y equals negative 1. Now let's graph into the calculator just to check. because if you don't know, you can always type it in here. I go to on alpha y equals 1 divided by x plus 2, and then minus 1 out here. I show you that picture. Yep, looks just like that. Alright, so again, there's two asymptotes, a horizontal one and a vertical one. Graph them, then there's your 4 sections. Always draw on the top right, and then just alternate unless a is negative. Alright. Example 3, sketch this. Well, again, step 1, find the vertical asymptote, set the bottom equal to 0. So the denominator equals 0, I subtract 1 both sides. X equals -1. That is my vertical asymptote. Alright, find my horizontal asymptote. Well, that's my k. K equals -4. So that's my horizontal asymptote. Now I just make a quick sketch. So draw my axes. Draw your asymptotes first. X cannot be -1, so let's call this -1. So -1's right there. K is -4. I like negative numbers for some reason. Just call -4 right here. So that's -4. I now draw my curves. Now A is negative, so I do not start on the top right. I start on the bottom right. So look like this. Curves out, follows that, starts going downwards. Let me extend this. Yeah, that should be straight. And other side comes up here, goes down here, and it flattens out. There's my picture. Again, a hyperbola, domain and range. Basically all reals except for our asymptotes. So domain is everything but x cannot be -1. And range, everything but y cannot be -4. Alright, let's see. If you wanted to be more accurate, we could do the starting point 1, a. So it should start at 1, -3, but this moves according to h and k, remember? H is left 1. So let me shadow this, or let me do this. So if I was at 1, -3 would be right here about. It would go left 1 and then down 4 to this. That point should be 0, -7 if you wanted a start point. Now again, I just need you to know the general shape where the curves are and the asymptotes, but let's check that. Let's see, -3 on top, on bottom, x plus 1. On the right side, -4. Graph that. Looks like that hyperbola. Let's trace 0 and see if we get -7. We do. So 0, -7 is a start point. Alright, so that's it. Here's the practice problem. Try it. If you can get that, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.